Hi class, so today we're going to cover what's called u-Substitution. U-Substitution will be our first integration technique for our integration toolbox. As we go through class, we're going to do many examples involving u-Substitution. We'll see that it actually undoes chain rule differentiation, which will be how we motivate a lot of these examples as well. And in particular, what I'm hoping that we all do today is recognize when to use u-Substitution, when is it appropriate to apply this technique. In other words, we're going to see that it always involves a product of functions inside of that integral. And what we need to figure out is, what do we actually call u to use this technique? So for example, we're going to be considering integrals that look like the following. Say we have something like 7x squared all times sine 3x cubed. And now if we just stare at this integral, we don't know its antiderivative just outright when we look at it. So we're going to have to start thinking about, well, we're going to develop these tools that we can apply to figure out what the antiderivatives are of some of these integrand functions. But what I want us to look at today is, for example, we're going to see that there's a product of two functions, this 7x squared and this sine of 3x cubed. And for us, we have to think, well, is u-Substitution going to be appropriate? And what I want to recognize right now is, well, we have this 3x cubed piece inside of that sine function. And now if we differentiate that 3x cubed, say we just come across and hit that 3x cubed with the derivative, this is just a side calculation now. We get that this is 9x squared. And well, if we compare what we have here, we see we have this x squared component coming out of its derivative, but we also see this x squared component sitting out there in front of that second function. And this is going to be indicative of, hey, one of these pieces of this integral looks like the derivative of the other, which suggests u-Substitution might be appropriate. And while we're going through these examples, we're also going to be able to see how to perform change of variables in calculus. And we need to remember that we're not only going to substitute what we call u, but we also need to switch that integrand differential from a dx to our new variables in terms of du as well.